Okay, welcome back. This is just a short video to talk about all the things that you supposedly have learned from Chapter 2, just to reinforce your skills. So we're going to just do some stuff. This is very remarkably similar to what the assignment is going to be. So first thing, I have a new database here, but I don't really know much about it. So one of the things I would do is I would go look at the database diagram, so to speak. So I'm going to go over here to the database tools and look at the relationship. So I have a thing called prison, which gives the prison name, its address, etc., and who the warden is, and then the cells that are in that prison, and then the inmates that are assigned to those cells. Okay, that's about it. Okay, cool. So let's just start. If I said, give me a list of all inmates that are from prison number 1, 2, 3, 4, what would you do? So I'm going to go here to the query design, blow this away, get to the SQL view. Okay, here we go. So this would be like select asterisk from inmates, right? And then I would say from, because I asked specifically about all the inmates that are from one particular prison. So where prison ID is equal to 1, 2, 3, 4. Kind of straightforward. Boom. Whoops. Oh, ha ha ha. I got it in there. That's supposed to be a where clause, isn't it? Where? Okay. What? Okay, good grief. Yay. Okay. So the idea is that, just simple where clause. If I ask you, give me all this, where that, kind of a thing. The next one I want to do is about string pattern matching. For some reason, students have a tough time with this. I'm a little perplexed by that. So instead of having give me a list of all inmates from a particular prison, how about give me all inmates whose name start with the letter J? Okay? So where the prisoner's name, okay? So I'm going to say inmate name, and then instead of saying equals, I'm going to say like. So when you're doing string pattern matching, you don't say equals, you say like. All right? Cool, like. And then I want to have something else in here. Now, if I wanted to find everyone who started with a J, then I want to have J and then a wildcard. The wildcard essentially says, I don't care. So J plus I don't care, right? That makes sense? J plus I don't care. So J and then so anything that starts with J. Cool? J plus I don't care. So you get everybody who starts with J. All right. Now, let's reverse that. And so this time I want to say everything that ends with the letter T, which means I have to have I don't care first, then followed by the T, right? That makes sense? Where does the I don't care go? Does it go at the beginning or does it go at the end? Well, it depends on what I'm asking you. If I'm asking you for things that start with J, well, then I want J plus anything. If I want to have something that says, give me all things that end with T, well, then it'd be anything T. See how that works? So this is just going to be like that. It's not case sensitive either, by the way. So this will give me everything that ends with a T. Cool? All right, kind of makes sense. You can't actually see that ends with a T, but it does. All right, cool beans? All right. Now, the date format in Microsoft Access is a little strange. And again, I somewhat hesitate showing you the intricacies of Microsoft Access because we're going to leave Microsoft Access behind and start using SQL Server big time. But I'm going to do an example just the same. So what if I said I want to find out all the people who have been there longer than August 1st, 2019. Okay? So I want to find out where their start term, is less than, you could do that with dates, right? Date. Except that the date format is just doggone funky. It's just a little pound sign thing. So 8/1/2019, I think that's what I said, with the pound sign. So date literals have these goofy little pound signs on them. I don't like this. I don't like showing it to you, but because later on we're not going to be using that. We're just going to use single quotes and we'll be done. So here's all the people whose start term is before that. Hey, what if I want to find out all those people who are not eligible for parole? For example, their earliest parole column is null, right? That's exactly what that means. Where this time it's going to be earliest parole. Earliest parole is null. Okay, that means where they don't have anything in that column. Okay, so we got two inmates, Dave Smith and Jane Doe, who are not eligible for parole at all. Okay? Okay, let's do one with ranges. I don't actually have that much stuff here, but give me a list of all cells within the range of 100 and 105, something like that. So there's two ways you could do this. You could do this with a compound thing. I mean, you really could. But it's actually easier if you go in here and just say cell number between 100 and 105, or 4, whatever it is. Okay, now, if you're using numbers, you don't put them in quotes. But if you're using strings, you do put them in quotes. So this is one of those that you'd have to really go look to see, hey, by the way, can you always just look and tell whether or not something is a string or by just looking at it? Well, here's a hint. It's not exactly perfect, but see how the text is left justified and numbers are right justified? Ooh, isn't that pretty cool? All right. So for example, if I get down here where the cell number is justified to the left, therefore it's a number. Cool. That kind of makes sense. Now let's do another one of those, except this time we're going to do it a slightly different way. Instead of doing the between, I'm going to leave that up there. It just has a marker. I'm going to say select asterisk from inmate where cell number. I could have done it this way. Cell number is greater than or equal to 100 and cell number is less than or equal to 105. Do you see how those are actually the same thing? Really? I mean, they're kind of sort of the same thing. So I'm going to get rid of this. And this should give me the exact same answers it gave me before because they're equivalent. Now I'm going to do the logical opposite. So first of all, before we start doing logical opposites, what is a logical operator? What is a comparison operator? What are those things? Can you look at this and tell me what those things are? Well, to me, that is a comparison operator. And that is a comparison operator. And that is a logical operator. So there's a total of 3 operators, right? Nod your head. 3 operators. Good. 2 comparison operators and 1 logical operator. When it comes to doing the logical opposite, you're going to have to do a conversion on every single one of those things, all 3 of them, where cell number, so what's the opposite of greater than or equal to? Well, it's less than. What's the opposite of and? Well, it's or. What's the opposite of less than or equal to? Greater than. Okay? That kind of makes sense how we did that. Okay? This is not going to give me any answers because I don't have anything in that range. So the query works. It just doesn't produce any output because I don't have anything that fits that criteria. Okay, so we've done logical opposites. Good. Okay. Let's do another one of those that's kind of sort of similar to this. So instead of doing it this way, I'm going to say where cell number is inside a range of I pick, for example. I go in here and I say in, and then I give it a list of things. I'll take 100, 102, 105. Okay, now once again, these are numbers, so they're not in quotes. But if it was a string, then you'd put them in quotes. Okay. And how do you tell? By looking at the data, how can you tell whether or not it's a string? I mean, for example, if I put a zip code in there, sometimes I might want to put zip codes as numbers, and sometimes I might want to put zip codes as strings. You're going to have to go look to find out. Let's see how this works. Yay! Okay, kind of makes sense. So that's basically 3 different ways to do a range of values. You could use the between, you could use one of those compound things, or you can use this set list operator, which uses the in keyword. Okay? Okay, let's get a little bit more complicated here. So let's do the average serving term for an inmate. All right, so this time I don't want to do a select asterisk. So if I just did serving term from inmate. Okay, let's just start with that. Okay, so that's the average serving term for my inmates. Great. Now I want to do something. If I said, give me the average, well, then that's going to be one of those things where you're going to have one of those vector aggregate guys. I'm going to say, average. Put this in there like that. And then it's going to do some math for me. And ta-da! The average is 32.2 years. Kind of makes sense? Cool. So if I ask you, how many cells are there in each prison? Listen to the words. In each prison. How many cells are there in each prison? Each prison or by prison. Those are the key words that tell you, oops, I'm going to need a group by. Okay? So pay attention to the wording so you can tell what it is that you're supposed to be doing. So for example, here I'm going to say prison ID, and then I'm going to have something. I'm going to leave that blank for just a second. And then from cell. Okay, so far so good. So what I want now is if cell contains all of the cells, right? Of all the prisons. So I really want to count them, okay? So I could go here and just say count, and it doesn't really matter which field I'm counting on. I'm going to count on cell number. Okay? Now, is this going to work? What? I can't do that. How come? Well, because you have to do a group by. So here I do group by, and then tell it what I'm grouping by. Well, I'm grouping by prison ID. Because I asked you, give me the list, give me the number of cells in each prison. Okay? So, ta-da! Prison number 1, 2, 3, 4 has only 3 cells, and 2, 3, 4, 5 has 2 cells. Okay? Kind of makes sense? Okay. Hey, we're coming up on the 15-minute mark. Let's just take a break, and we'll finish this again in just a few.